Hi everyone. We're about to start if you'd all quiet down. So this is Programming for Beginners or Programming 101. We're going to go through basic topics like variables, what the different colors mean, what is programming. So for a general idea, who here has ever programmed before? Okay. Who here is on the programming team with the robotics? Okay. All right. So did you guys learn programming with school or just on your own as interest? School? Okay. So first up, I'm Gabby. This is my third year on SWATposium, and I'm the new lead programmer because our last year programmer graduated. So I spent a lot of time on autocode and particularly cameras and coders. We worked a lot with like PIDs last year trying to get it to move our shooter and stuff like that. So I'm going to go through what encoders do. But just kind of generally, there's another programming workshop this afternoon focusing on PIDs. So we're not really going to go into that. And then I'm actually graduating this year, but I'm hoping to go into mechatronics at Ryerson and Waterloo. And I'm hoping to stay involved in first. I'm probably going to come back and mentor SWAT if possible. So what is programming? Programming is the action of writing code, particularly to communicate with the robot for FRC with a set of instructions and commands. So the most general thing is drive. We spend a lot of time programming motors. Pretty much everything is run with motors other than pneumatics, which is kind of a more complicated system. So everything goes through the motors, so you spend a lot of time programming motors, and the good thing is all motors are programmed more or less the same. So once you know how to program motors, you can program your robot to do just about anything. Same thing with the operate functions. This year we had a shooter, so it's making a motor spin. Same thing as driving. Last year we had elevators, so the motor was spinning the pulley, which was making our elevator go up and down. They're all kind of the same thing. The other thing is the function and analyze. So that's more particular to sensors, where the robot will, you'll get the robot to bring you back input from whatever sensors you're having, like encoders or things. And then you'll tell your robot to make a judgment based off what your sensors are saying. So that's a bit more complicated, and it's kind of helping the robot to make decisions on its own, which makes the job a lot easier for your drivers and operators, but it's a bit harder for programming. So programming is the link between how you guys see your drivers driving the robot and the hunk of metal that's sitting in front of you, because programming, when I first joined robotics, I didn't really think programming was a big thing. Like I joined robotics to play with the robot, but without programming, your robot is a hunk of metal and it doesn't move and it doesn't do anything. So programming is actually a really important subteam, and it's really good that you guys are all interested in learning about it. All right, so if you ever coded before, particularly with Eclipse, my team uses Java, so you'll see Java examples. We have different colors, so we have purple, black, and blue. And they're not totally random, they actually mean things. So purple is generally command categories like public class. So that's the command where everything in public class is under that, and it's like a category that everything sits in. And public class holds all this information. So double holds all the information about like shooter motor factor. It's like just how our computers have gigabytes. You know, it's like, oh my god, like I got a new iPhone. It's 16 gig or whatever. That's what these do. They don't hold gigabytes. It's not that big, but it's the same general idea. Double is capable of holding a certain amount of space, and so on and so forth with other rules. And then the blue is names. So we try and name things that make sense, like shooter motor factor, our joystick drivers, the joystick that the driver uses to control the robot. But you can name it whatever. We have some coders that name them totally random things. I've seen projects called like pink rainbows, and you can do whatever you want. It's totally up to you, but it's generally better to name it something that makes sense, or else, especially if you have a bigger programming team, or else one of your other programmers is going to look at your code and they're not going to understand anything because none of it is in a logical order. All right, so we're going to talk about variables. Do any of you know anything about variables? A little bit? All right. Does anyone know anything about a byte? What is a byte? Yeah?
6 bits.
Close. 8. Yeah. Awesome. Here.
Oh.
Catch. Yeah, we have candy. So a byte is a number that takes up the space of one byte or 8 bits. So 8 bits holds a minimum of negative 128 and a maximum of 127. So the general code is -2, and then you take your number of bits and you subtract 1. And then down here you do the same thing, except you subtract 1 from the final number, so 128 and 127. So if my next number is a short, how much space do you think it takes up? Or how many bits do you think it has? This is 1 byte, and short's a bit bigger. Yeah?
16.
Yes. Good job. Thanks. All right, so short, it's once again a number. All the ones on this page are numbers. 16 bits, same general code. The next one is an int. Anyone have any idea?
32. 32.
Yes. Awesome. Thanks. So 32 or 4 bytes holds the same number. I find that we use int the most often with numbers. It's kind of rare that you're going to have a number that's going to be as small as 128. If you look at your motors and you look at the amount of power it has, usually you're sending a lot of voltage and things, so that's not ideal. We tend to use integers just to be on the safe side. You'd rather have more space and not use it than not have enough space. And the last number that we're looking at is long. Yeah?
I think it's 64-bit and it starts with like 9 quintillion 220.
Okay, I'm super impressed. You're getting a handful of candy. I did actually not think anyone would know that number, so.
No, like the first 4 digits.
That's impressive. I didn't even know like any of it, so you're doing better than I am. All right. And now we're going on to float. So does anyone know anything about a float? No? All right, the first one is called a float. How much space do you think it takes up? It's a bit bigger than the first two. Any ideas?
32.
Oh, yes. Awesome. I don't think I can throw that far. Okay. Nice catch. All right, 32. So a float is a floating point. So it's used more to save arrays, which are generally like a series of numbers or characters instead of one specific point. So you shouldn't use these for specific values like money or 1 to 10, because there's not really a point in using something like a float that's used to hold multiple numbers if you're just looking at one. So a float is for large arrays. And the next one we have is a double. So if a float is 32.
64.
Is that you? Yes. And a double, once again, double precision, 64-bit floating point. And this one is generally the default for decimal values. So once again, shouldn't be used for specific. There's not really a point in using it for those, but it's used for large decimal values or things that are going to hold more places. And then we have others. So char. Any idea? Sounds really similar to an English word. It's the first 4 letters of an English word. Anyone? Yes?
Character.
Yes. There. Heads up.
Oh, great.
Any idea how much space it takes up? Blue?
2 bytes.
16. Nice try. Oh, no, that was right. Yes.
Yeah.
Oh, sorry. All right, so A, B, C, D, E, F, G. We all know the alphabet song. I'm not going to sing the entire thing. But a char is a single 16-bit character that holds that space. But it's any one letter, so you can use letters as variables instead if you like. So if a char is 1 letter, what do you think a string is? Yeah.
2 letters.
A bit bigger than that. You want to guess again?
4.
Close. 6. No, it's not a number.
It's a century.
Yes. Well, more or less. No. A string is a sentence or a word. So a series of characters. So I mean, in FRC, we're not really going to be using sentences. Something that my team likes to do is we'll use Smart Dashboard, especially with sensors. It helps you see what values your robot's getting. So it allows you to know when your button's pressed. That way, if you press a button and nothing happens, you know it's not that the button's malworking, but that the robot isn't reading it properly or something like that. So we, in our Smart Dashboard, will print hello, and then if we're having connections to the robot says hello back to us. It's the only time I've ever really used a string. I don't participate. Yeah?
What's the maximum length of the string?
It says it's 2 to the 31 minus 1, so that would be the same thing as a integer, I believe. You can go back and see the value for integer.
Yeah.
Yep, so that long number.
That's a lot of space for me.
All right, and we have one more. So what about a Boolean?
Oh.
Black.
Okay, it's either it's true or false, isn't it?
Yeah. All right. Okay. Can anyone give me a real life example of something that would be a Boolean? Something you use every day.
Computer?
Yeah, a button on a computer would be a Boolean. John, here. The one I had written down was a light switch. So your light is either on, well, not in the super modern ones when you have different dimnesses, but in the lights like in these costumes, you're either on or off. So it's one value or another. We used it in limit switches a lot because it's the only two options. So 2 years ago we had an elevator, and that way our elevator didn't just keep going and fly off our robot. We had a limit switch at the top. So when the limit switch isn't pressed, the elevator keeps moving, and when you press the limit switch, the elevator stops. And all your buttons on all your controllers, they're either pressed or unpressed, so that would be a Boolean. All right, we're gonna look at the difference between a command and an iterative robot. I had a bit of trouble understanding this when I first started. It's not the easiest concept, but think of reading a book, and every time you come across a new character, the book doesn't give you any background information on the character whatsoever. So you need to go off and you need to read a little side story about that character. So after a while, you get a really in-depth understanding of the book because you've gotten all this information on the other characters. But it means you have to keep looking at other places. So that's kind of what command-based does, is I'll get down to, wanting to get the robot to drive, and then I'll have to go into a separate piece of code and look at what it's saying about driving. Or if I want my elevator to move, I need to look somewhere else. So or my buttons or anything like that. So it separates things into separate pieces of code or separate books, and it allows you to program them all separately, which is really good if you have it tends to be really good if you have a bigger drive programming team, because that way it's not everyone looking at one file. You can, send someone off. I want you to program the elevator, program the drive, the buttons. So make sure that everyone kind of has a job, and at the end of the day, you can bring it all together. And it's also really, really good for debugging, because what happens when you do a command-based is you can thoroughly test that function to make sure that there's absolutely nothing wrong with it. So once you know that, if you run into an issue with your robot, you 100% know that it's not that, because changing anything else in the code will not affect that book. So it doesn't matter what you change in the big one, that book doesn't change. So you know that there's no issue in there. Or if you haven't thoroughly tested it, and an issue does come up in there, you don't need to look through your entire code to find out what breaks. You can just go to that book and fix that. So it makes debugging a lot easier. It means that a lot more people can program, but it is a bit more of a complicated model because your files are all over the place. Iterative robot, that's what my team tends to use. I find it's a simpler model, especially if you're starting. You're not running all over the place, calling different functions. Your code will tell you, I'm missing this, I don't get what this is. So that's what we're using, and that's personally my favorite. So it's one big book. When you read a book, you get to a character and it tells you background information about that character, and then when you hear about the character later on, you know in your mind that you're referring back. So that's what the robot does. It'll read through and it'll come on to a function that's not all the information is written there, but that I'm calling it up, and we'll go, oh yeah, I remember you told me about this earlier, and we'll go look at what you said earlier, and we'll come back and we'll be able to work. So it's more like one big book instead of separating to different functions. So it's a bit easier to program because everything's in the same place, but at the same time, you can run into issues because if you change one thing, it may affect other pieces of your code. So when you have a bug, you need to read through your entire code. And my team's code gets to like 800, 1,000, 2,000 lines. So if you have 20 minutes to read and fix the problem because you have a match next, and you have 2,000 lines to read, you're going to be reading for a while, and you might not get it fixed. So it's got a lot of advantages, but it's got some downfalls. So it's all up to you to make that opinion for yourselves. All right, so we're going to look at the different classes. So when you first turn on your robot, you have robot class. So this is where you initialize variables. So this is where you'd say, hey robot, I have 2 joysticks, 4 talons, I don't know, a timer, an encoder, things like that. So this is where you initialize all of them and let the robot know what's going on. So it's kind of like when you get to a book that's got a lot of characters in it and like gives you an index of all the characters, and like Game of Thrones doesn't give you an index of like all the characters and what houses they're in or something. It's kind of the same concept. Robot init, that's what the robot first reads when you enable it. So it just goes through, and that's what tells the robot more specifically like what it's connected to. So up here I'm just saying like I have 4 characters in this family and 10 characters in that family, and down here I'm saying so in this family I have Bob, Jill, and Mark, and in that family I have this, this, and this. So it's specializing and like labeling things, that way they're more individual and the robot knows exactly what it's talking to on the hardware when you mention the name. So it kind of makes it easier for programmers because we don't have to call a specific hardware, we can just call Sally. We don't need to specify where that's connected to. Autonomous init, so it's what the code first reads when auto is turned on. So init is one of the ones that doesn't run on a loop. It just reads it once and then it goes back to periodic. It goes to periodic. So what we like to do in init, just to be on the safe side, is we'll 0 all of our motors because you don't want you turn your robot on, next thing you know, you're like running over the person, someone in front of you. So we always 0 all our motors. It just makes sure that the robot doesn't move unnecessarily when you power it on, and then you'll give it any extra variables or anything that you want. So in auto init, if you don't have a like encoders to tell you the driving, we often use timer. So we'll say like start autonomous timer, and then between this time and this time, drive here, and between this time, do this. So we start a new autonomous timer in autonomous init at every match, because if not, then your timer would get stupid long from past matches, or you would have to reset it like by hand. That's not super useful. And then autonomous periodic is where it reads it on a loop. So 5 hertz. So 5 times a second, 0.2. It takes 0.2 seconds to do one loop. And all periodics run for FRC on 5 hertz. So same thing for teleop. Autonomous is where the robot drives itself. So that's a bit more of a programming job because you're specifically telling the robot what you want to do, at what power to the motors, how fast, how far. So that's kind of the programming time to shine. I really like it. It's a really cool feeling to like when you program it just right. This past year, at the beginning we had issues. We were running into the barrier at the back. And I don't know if any of you know, but that was happening so frequently that FRC like put in a rule that you're like not allowed to smack into bears. It's causing comm issues. So I think they even like inputted a foul or something. So we were playing around with the autonomous, and there was a time that we got it to glide and it stopped like this far from the barrier. It's a super proud moment for the programming team because we felt like we'd done really well. We stopped it just where we needed to. We've had a robot like spin in circles and do funny stuff. So autonomous is always like a good period to like for your programming skills to shine. And then teleop is all driver related. So usually in teleop periodic, you'll just say, call forward these buttons, call forward these joysticks, call forward this information. So there's not as much coding there. You're just kind of calling forward functions that you're going to need. All right. So does anyone know what a public class is? Public. We all know what public is.
Guessing anyone can access it?
Yeah. Awesome. Okay, so yeah, public is accessible, overall accessible anywhere in the code. Private, anyone?
It's accessible only when something is, when only a certain condition is met.
Yeah, more or less. Whoop, it's not the best throw, my bad. So accessible only in that class. So at least in iterative, we have public class robot, but I could have public class machine, stuff like that. So this private is only readable in public class robot, but if I had another public class, I wouldn't be able to read what was in here, but I would be able to read what's in here. So I don't really see the need to call make more than one public class within your drive code. I don't really see why you do it, but some people might, so it's good to know. So private is only readable within that class, and public is readable anywhere. What does the negative mean?
Reverse direction.
Yeah. All right, more specifically, because I don't know what that means. All right.
I'm guessing left or down.
Sort of.
I'm not sure if that's X or Y.
The concept is more that motor is running in inverse. So motors have one direction that they know is like forwards. So if I put the motor on this side of the robot, it knows this is forwards. But now if I flip the motor this way, it thinks that this is forwards because it's always turning to the right. But then those two motors going opposite directions. So you need to 0, 1, or -1. That way they're both going in the same direction. So it's like inversing the motor. It's just to know which one. That way you know like which one's going forward. There's no, unless your team is like super specific about motors. A lot of the time you'll stick a negative somewhere and then they'll turn the robot on and you'll find it's not doing what you want and then you'll change it. Because you'll stick the negative on the wrong side and the robot's going backwards, not forwards. So, but there is a way to avoid that if you know specifically, what direction the motor thinks is forward, and then you know what talon that motor is connected to. You can do it a lot more specifically. All right. If and if else. So has anyone ever used if or if else before? Yeah? All right. Can anyone tell me what it does? What it means? And yeah.
If there's like a statement where you put in a condition,
Yeah. And what happens if the condition is met?
it runs the code that's in the if statement.
All right, so just like you said, a condition statement where nothing occurs if the condition isn't there. So if that condition is met, it runs this code, and if the condition isn't met, then it doesn't do anything. So this is our autonomous timer, like I was talking about earlier, how we set a time. So between this time and this time, do this, and this time and this time, do this. So if it's, at 10, it's not going to do the first one because the time isn't between those two. So it's only met if it's at that timer. Another time that my team personally uses if is with reading through our joystick. So you can use if else, but we can use it. So if generally when the button is not pressed, it's read as false, and when the button is pressed, it's read as true. So it just says if this button on this remote is true, then do this command. So it reads, it goes, it's not true, okay, next one. It's not true, next one. It keeps going. And if nothing is true, it just, now you're being really loud. Sorry. It just keeps looping. All right, so if that's if, then what's if else?
If it's just like except that when it doesn't do that command, it doesn't know.
Yes. Oh, that's my if else code. All right, so a condition statement where if the condition isn't true, the code does the else, what the else statement says. is a little bit complicated. We're gonna go through it. It's something my team likes to do. We tend to have drivers that like going really quickly and drive kind of aggressively, and just like on the road, aggressive drivers can sometimes crash into things, and you don't really want to crash into things when you're at versus your robot, because you don't tend to have a lot of time to fix it. So we put in something called a max threshold. So the whole idea is that even if I press the joystick to like all the way down, if I set a band that says after you press the joystick like 80% of the way, don't like go any faster than that. So it'll go, is the number over 80? Yes, then I'm going to return a value of 80 or X. So when you press X, it just means that you can make the threshold whatever you want, and it'll return the last value. And if it's not over that, then return the last value of X. So, and then our threshold was, you know how you draw a circle, it's like really hard to find the middle? And there's always like mechanical issues. Well, not always mechanical issues, but like it's really hard to find the middle even for like professionals. So we put a little circle in the middle of our joystick. That way if someone like blew on the joystick, if the joystick wasn't perfectly centered, our robot didn't start like slowly inching forward. So it's just like a tiny circle, and if the joystick is within that, return 0, so don't move, and if not, return, and if it's not within the like overall loop that we said, then return the value of X. So that's an if-else statement. So if this is met, return that, and else. So if not, then do this. All right, so creating and initializing variables. It's kind of a cool one. It's a bit complicated to understand. I had some trouble with it. I know a couple people on my programming team had trouble with it. So show of hands, how many people played Pokemon Go? Yeah, most people? Awesome. My next example a little bit depends on Pokemon Go. So as you can see, we have Can-Talon, which is right motor 1. And then here we relate right motor 1 to new Can-Talon 1. So saying I have a Can-Talon is like saying Pokemon Go. So within Pokemon Go, you have different types, right? So within Can-Talon, I can call right motor 1 whatever I want, and it's going to be a different type. But once I link right motor 1 to Can-Talon 1, it's always Can-Talon 1. So Pikachu is always going to be electric type. These are always going to be connected. But I can have right motor 2, right motor 3. I can have different, even though they're all electric type, they don't all have to be Pikachu. So I can connect them all to different things. So for non-Pokemon players, it's like if you look at St. Mildred's. This is one school out of many. So just like Can-Talon, we have joysticks, we have other things that we have cameras, we have other things that we can call forward. So St. Mildred's is just one of many schools out there. And within St. Mildred's, we have science. So science is a specialized branch of St. Mildred's, just like we have other fields. And a type of science is biology. So biology is always going to be considered science, but there's other sciences other than biology. So right motor 1 is always going to be connected to Can-Talon 1, but if I stick a right motor 2 or a different name, it's going to be connected to something else. But that doesn't mean the fact that bio is always connected to this. Because I said that this was a Talon is always going to be connected to this one, because that's what I specified as. Does that kind of make sense? Nods. We're all very confused and no one understands. All right, we have 2 people that understand. They're on my team, but whatever. It's 2. I'll take it. We can always come back to it later. All right, so buttons on a joystick. Kind of a complicated concept, but it's one that once you understand it, it's kind of one of those things that you're always going to understand, but it looks really confusing. I mean, what does k between 1 and equal less like 8, and then why are we adding 2 k's, and like what is happening? So we're saying that we're saying that we have these 2 joysticks, and then we're saying that within the joysticks we have buttons and that they're booleans. So we call them, and then you have to read input. So this is during how I was saying in IntelliOp, you just like call up different things. So this is one of the things that we call IntelliOp. So what this is saying is that we have buttons between the value of 1. So we have buttons 1 to 8, and after every one, you add another number. So I have 1, and then after button 1, I have button 2, and after button 2, I have button 3, so on and so forth until button 8. So, it's like everything else. If I tell you I have a number between 1 and 8, if I have all numbers between 1 and 8, you know that I have 1, 2, 8. But the computer, or the robot, more so reads it this way. So it's just saying that after value of 1, you add a value of 1 until you get to the value of 8. So, and then you can program each individual things. And my team uses an Xbox controller. Thankfully, we don't need to program the Xbox controller. It's all already there. So you can just Google coding button values for Xbox controller, and it'll tell you like this is button. I think button 1 is green, button 2 is red, button 3 is yellow, and button 4 is blue. I think. So it'll tell you specifically like what number every button is. That way you're not just like smashing buttons trying to figure out what they do. Or on your smart dashboard, there's a place that you can look, and when you press a button, it'll tell you what button it is. That's also really useful. So that's kind of how that works. All right. So a really good tool to use besides your mentors,
There's a question here.
Oh, sorry, go ahead.
So the programming languages is JavaScript and Java.
Our team currently uses Java, so you can use, there's 3 different languages in FRC. There is, I think it is JavaScript, more specifically, but we just call it Java. So you can use Java, C++, or LabVIEW. So it's all kind of personal preference. When my team started 15 years ago, they used Java, and we just haven't really switched ever since. I wouldn't really say that there's one that's better than the other. I think it's kind of personal preference. LabVIEW is more of like a click and drag boxes. If you guys have ever done FLL, how you have like boxes that you drag with like different instructions, that's a bit more of like how LabVIEW works with like a flow model. But Java and C++ are really close. They just have like different syntax or like grammar. Make sense? Okay. So besides your mentors, one of the really great places to look is Google. Even with our mentors, when they don't know something, they'll Google it. We have some mentors that have worked in the field for a really long time, and they still don't know everything. Coding languages are coming out with updates and new ways to do things and shortcuts all the time. So you can try as best as like stay on top of everything, but you may not know everything, and that is totally okay. You don't have to know everything. We're all just students. Like, we're regularly Googling things. There's a bunch of resources up there. There's Chief Delphi that'll have information, stuff like that. So you don't know something, ask your mentors, and if they don't know, ask Google. Does anyone know another resource? Specifically FRC.
Chief Delphi?
Yes, but it's more specific to programming. It's a programming library. Does that mean anything to anyone?
Stack Overflow? Stack Overflow?
No, I don't actually know that one. I'll have to check that out. No? All right. You guys are all going to like this then. This is the first FRC control, but more specifically, it's WPI-lib. So it'll tell you exactly how you set up if you want to program in LabVIEW, Java, C++. It'll tell you exactly how you set them up, how you download them, what you need to put on your computer. It'll give you tips for wiring things, setting up driver stations. You can download things. It talks a lot about sensors. Really, really great tool. I highly suggest using it. I don't know where I'd be without it. It has a lot of really great information on there from just about anything. If you're having talent issues, if you're having connection issues, if your robot doesn't work, it goes through troubleshooting, what brownouts are, how to manage your CPU, anything like that. WPI-lib is an amazing place to look. And within WPI-lib, I will make sure this gets to you guys because I had a terrible time finding this. I spent like 2 hours Googling to find this thing. So save it, bookmark it, don't lose it. Really useful. So this is the code library. It gives you pieces of code. It tells you how specifically you need to use things, how they're used, how to call them, the different ways to call them, different ways they function. So when you call something forward in your code, you generally need to download something. So when you originally open a new packet, like a new project, it'll already have stuff downloaded for you, like iterative robot and things like that. But you'll need to download if you're using buttons, if you want to use a camera, if you want to use things like that, talents, you just go here and you download the package into your clips. WPLib has been really nice for us, and those talents that we use actually have a bunch of code written for them, and we don't have to do it. It takes forever. So WPLib has been really nice, and they program all of that for us, and they have it all up there for us. So all you need to do is click on it and download it, and you don't need to worry about it. And also a good thing is, if I want to use a gyro or an accelerometer or anything like that, I can go on there and it will tell me when you're trying to start the accelerometer, type this. When you're trying to end it, type this. When you want this information out of it, type this. It's a class. It uses this, this, and this. It needs these variables, things like that. We thought it was really useful for vision code. We had some issues with vision code this year. So we use this library a lot, tried out different things. It's got a whole list. I'd highly suggest using it. I know, it's a really great resource.
And that's on the website?
Yeah, it should be a link off the website, but I had issues finding it at one point. So this PowerPoint will be going up on the SWAT 771 website within next week, and I will make sure that the link is on there so you guys can all find it. And now we're going to talk about sensors. I think we have enough time. When does this end? 10:50. Oh, 3 minutes? Okay. Sensors! So within sensors, you have different types. So the most common is robot orientation. We all know how compass works because we use north, south, east, west, or any combination of. So you can have a compass that tells you how far off like that original point your robot has turned. You have gyros, which convey orientation. So they'll, when you see teams that are like super, super picky about where they place their robot on the field, it's generally because they're using something like a gyro. So they have their original point and they know that from this point, like especially 2 years ago when there was the gold totes that you could pick up an auto, they know that from this point, if they go forward this much, pick up the tote, move around the green, they're going to be able to pick it up and they're going to be able to do it perfectly. So gyros work really well, but you need to be really careful about where you place them on the field, because if you're off too much, then your robot does the same pattern, but it's going to knock over a bunch of things. It's going to crash into other robots. Doesn't really end well. Accelerometer, it measures the proper acceleration. So there's different types of acceleration that measures. Some of them measure it from like the perception of the acceleration of gravity, but this measures relative to the force of inertia. So when it's moving, how quickly, around what bends, things like that. And then rangefinder measures the distance from the robot to the target. So we used them 2 years ago. We had them on a robot when we wanted to line up the totes. So we had one on either side. So when if you see the robot, if you see a tote on this side, like move this way until neither sensor sees the tote, and then move forward until the middle one does, and then you can pick it up. So it helped us position. It's really good for doing things like that if you can write code for it. I'm going to come back to encoders if we have a little bit of extra time because they're a little bit more complicated. So potentiometer, the absolute angular rotation or linear motion of the robot. So angles moving, how far, kind of like this. I haven't really worked with potentiometers, so I couldn't be able to tell you a huge amount about it. I would rather just use, I think a potentiometer kind of combines the gyro and the compass. So 2 in 1 instead of having to place 2 sensors, but I'm not totally certain on that. It's not one that Mike intends to use. A camera, I'm hoping or assuming most of your team said cameras. It's kind of cool, you get to see the robot's perspective. Make sure you don't drive into people. It was really good this year when you had the really high, the portcullis that you can't always see on the other side. It made life easier. And then vision processing. So this kind of pairs up with the camera. So a lot of teams, or not a lot of teams, teams that had really accurate high shooting tended to use vision processing, because what they would do is how it had the reflective tape. They would do all this complicated process, but essentially, when they saw like a certain amount of green tape in a certain shape, it would line up until it was like in the middle of the screen, and then the robot would shoot. So it allows you to apply a target. Something that my team tried to do this year was, instead of doing that, we wanted to just put like a U shape, and then when the driver lines up the U with the U of the goal, you get the ball in. So it's totally dependent on how much you want to program, how accurate you want to be. The one with where they like targeted the reflective tape was really good, but it was kind of hard to get, and you had to get the colors just right. That way, it particularly identified like that shade and things like that. So it's a bit more picky with programming, but you'll be able to get more accurate results. And then the last thing is encoders. So encoders generally measure the speed or distance that you go. So an encoder, if you think of a CD, how it has like all the lines, like the information on it, and then when it goes around, your like drive will like read it. The same general concept holds true for encoders. So I think an encoder is generally black, and then you'll have a white stripe. It's something like that. So it'll be a disc with a different colored stripe on it. It's either black, white, and white, black. For visual encoders, there's magnetic and a bunch of other things. What happens is the disc will turn, and every time it sees a stripe, it'll count. So like a rotation per unit. And then you have your encoders hooked up to your motors, so that gives you can change that into speed. So it's really good for more specific, like moving, how far your robot's gone in a certain distance, things like that. So encoders are really interesting to use, and there's a workshop this afternoon called How to PID, which will be looking at encoders use PIDs. So thanks for listening, and I hope you guys enjoy the rest of SWATposium. Like I said, this will be posted on the website within the coming week, and we'll have all the information on it. So have a good day. If you guys have any questions, feel free to come find me at one point, or just on your way to the other workshop. And feel free to grab candy on the way out.